Good day, everyone. Our topic for today is permutation and combinations. So, I'll be your teacher for today, Ms. Mary Mante. So, let's start. Let's have our lesson 1.1, the permutations. Permutations is referred to different possible arrangements of a set of objects in which order is important. The number of permutations of n objects taken at a time is p quantity nr is equal to n factorial over quantity n minus r factorial, where n is greater than or equal to r. So the situations that involve permutations, the number 3 and number 5. So the number 3, which is the winning in a singing contest, and the number 5 opening the combination lock of your bicycle. So for example, there are 10 runners join a race. In how many possible ways can they arrange as first, second, and third placers? So there are only 3 placers. So there are 10 runners. So using the formula as to your solution, so P is quantity nr is equal to n factorial over n quantity n minus r factorial. So our n is 10, which is the 10 runners, and 3, our r is 3 because there are only 3 placers. So P quantity 10r is equal to 10 factorial over quantity 10 minus r factorial is equal to, let's copy the 10 factorial, over 7 factorial. And when you omit the factorial, in solving the factorial, you need to multiply all the numbers in descending order. So let's have 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over the same with the 7 factorial, 7 times 6, 7 times 6 times 5 times 4 times 3 times 2 times 1. So we will cancel 7, 6, 5, 4, 3, 2, 1 in the denominator and numerator. So the remaining in the numerator is 10 times 9 times 8, which is the answer is 720. So there are 720 ways, possible ways to arrange the first and second and third placers. Next lesson, 1.2, combinations. So let's define what combinations. Combinations, the number of ways of selecting from a set when the order is not important. The number of combinations of n objects taken or at a time is given by the formula C quantity nr is equal to n factorial over quantity n minus r factorial times r factorial, where n is greater than or equal to r. Situations that involve combinations. So a while ago, the number 1, number 2, and number 4. Remember, our number 1 is choosing 10 questions to answer out of 15 questions in a test is our combinations, which is the order is not important. Number 2, drawing a set of 6 numbers in a lottery containing numbers 1 to 58. And the number 4 question, the situations, selecting 3 people to form a committee. So these situations, they are combinations because the arrangement is not important. So let's have an example for combinations. So a soloist is auditioning for a musical play if she is required to sing in 3 of the 7 prepared songs. So take note, there are 7, your N is 7, your R is 3 at a time. So in how many ways can she make her choice? So your solution is using the formula. Again, the formula of combination is quantity nr is equal to n factorial over quantity n minus r factorial times r factorial. And C, quantity 3 is equal to 7 factorial over quantity 7 minus r factorial times 3 factorial equals 7 factorial over the difference between 7 and 3. So let's have 7 minus 3, it's 4, therefore 4 factorial times 3 factorial. Then let's simplify this 7 factorial. So let's multiply in descending order. 7 times 6 times 5 times 4 times 3 times 2 times 1 over the same with the factorial. So 4 times 3 times 2 times 1 and the 3 factorial, which is 3 times 2 times 1. So we will cancel 4 times 3 times 2 times 1, and also we will cancel 3 times 2 times 1 and 6, because the result of 3 times 2 is equal to 6. So the remaining number in the numerator is 7 times 5. Therefore, 7 times 5 is equal to 35. In short, there are 35. Therefore, there are 35 ways she can make her choice. So let's have lesson 1.3, the problem solving involving permutations and combinations. So let's see. Example. So let's have an example. Surigao City National High School plans to elect Board of Directors, BOD, composing teachers and parents. So the first question. In how many ways can the 6 members of the Board of Directors can be chosen from 10 parent nominees and 5 teacher nominees if there are 4 B must be if there must be 4 parents in the BOD. The second question, after the 6 members are chosen, in how many ways can they elect among themselves the 2 top position, president and vice president? So let's have the first question. So the solution for the first question, since the situation is forming a committee from groups of teachers and parents, it defines combinations. So to find how many ways, apply the fundamental counting principle. Thus, C is a quantity 10 times 4, is 10 and 4, times the another combination, C, quantity 5 and 2. So these have 10. Let's have 10 factorial over quantity 10 minus 4 factorial times 4 factorial is times the 5, the another combinations, 5 factorial over the quantity 5 minus 2 factorial times 2 factorial. So let's simplify. 10 factorial over the difference of 10 and 4, which is 10 minus 4 is equal to 6. Therefore, 6 factorial and 4 factorial times 5 is equal to 5 minus 2, which is 3 factorial times 2 factorial. Then, let's have do or simplify. So, we will omit the factorial. So, let's multiply the numbers in descending order. All of the numbers in descending order. So, 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 4. Times 5 times 4 times 3 times 2 times 1. So, divided by the same 6 times 5 times 4 times 3 times 2 times 1, and multiply by 4 times 3 times 2 times 1. And multiplied for another factorial, so 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1 times 2 times 1, the 2 factorial. So the result, we will cancel the 6 times 5 times 4 times 3 times 2 times 1. So the remaining of the numerator is 10 times 9 times 8 times 7. And for the denominator is 4 times 3 times 2 times 1. So in 10 times 9 times 8 times 7, the answer is 5,040. And 4 times 3 times 2 times 1, the answer is 24. And in the second combination, 5 times, we will cancel 3 times 2 times 1, and the remaining for numerator is 5 times 4, and the denominator is 2 times 1. So 2 times 1 is equal to 2, 5 times 4 is equal to 4. So let's divide. 5,040 divided by 24, it's 210, times 10 divided by 2 is equal to 10. So 210 times 10, there are 2,100 ways in finding in how many ways they are going to form a committee or groups of parents and teachers. Next, the solution for the second question. So, since the situation involves positions, so the order does matter. So, it is permutation. Thus, we will use the permutation formula. So in our permutation, our n is 6 and our r is 2. So is equal to 6 factorial over n minus 2. I mean 6 minus 2 factorial. So let's simplify 6 factorial, copy 6 factorial over the difference of 6 minus 2, which is 4. So 4 factorial, and then simplify again. 6 times 5 times 4 times 3 times 2 times 1 times 2 times 1. So you will omit your factorial sign. Divided by the 4 factorial, which is 4 times 3 times 2 times 1. And we will cancel the 4 times 3 times 2 times 1 because they can be cancelled by denominator and numerator. So the remaining is 6 times 5. Therefore, the answer is 30. There are 30 ways. The question, how we're going to summarize or generalize our topic. How did you differentiate situations that involve permutations from those that involve combinations? So, in your own words, you need to give your summary, your generalization. So, as we answer for that, the situation in which order is important involve permutations, while those in which order is not important involve combinations. And so we are done. So I'll give you the quotes from Gregory Willis of Birth of Niflheim. Life is full of permutations and combinations. Sometimes the order you do things matter, sometimes it doesn't. But in order to find the solution in life, you must work through each possibility presented to find your opportunity. Gregory by Gregory Willis. So that's all, and thank you.